Antarctica. Today, it's one of the harshest places on Earth, a frozen desert where knife-cold winds rip across endless miles of ice. Hardly anything survives out here, aside from a few battle-hardened penguins and seals. But beneath all that silence and snow lies a buried past. Scientists have found entire forests, frozen in time beneath the ice. And these quiet clues tell a wild story. Antarctica wasn't always cold and lifeless. It was alive, vibrant with lush green landscapes and inhabitants that looked nothing like anything alive today. A place where survival was just as brutal, but for very different reasons. The thing is, fossils from Antarctica are incredibly rare. Most of the continent is buried under miles of solid ice, but in a few scattered spots, cracks in the ice and exposed rock have opened little windows into the past. From the age of dinosaurs to towering birds and strange proto-mammals, it's a puzzle we're only beginning to solve. Our exploration brings us to the first time vault, the Hansen Formation. Tucked deep in the Transantarctic Mountains, this rocky outcrop sits right on the edge of Earth's memory. Back in the early Jurassic, this place was quite different. Volcanic landscapes, rolling rivers, and lush forests with temperatures easily hitting a mild 50 to 60 degrees Fahrenheit. Deep within the Hansen Formation, we meet one of its most iconic residents, Cryolophosaurus, the cold-crested lizard, the first carnivorous dinosaur ever discovered in Antarctica. It lived around 190 million years ago during the early Jurassic, and it wasn't just any theropod. Cryolophosaurus is a scientific oddball. Its femur has traits seen in some of the earliest meat-eaters, but its skull looks eerily similar to more advanced theropods from the other side of the world, like Sinraptor from China, which lived tens of millions of years later. This species is caught mid-shift, part throwback, part preview of what's to come, and nothing says that better than the crest, a curved blade of bone, equal parts armor and attitude. This crest wasn't built for fighting. It was too fragile for that. More likely, it was a visual signal, maybe to impress mates or help individuals recognize one another in the dense forests of Jurassic Antarctica. Because here's the thing, Cryolophosaurus wasn't just a predator. It lived in a complex, vibrant ecosystem. Standing up to 20 feet long and weighing nearly 1,000 pounds, it was one of the biggest predators of its time, built to hunt, tear, and dominate in a land that wasn't easy. And it may not have played nice. One specimen hints at something a little darker: cannibalism. The bones of a juvenile Cryolophosaurus were found bearing telltale marks, deep grooves and scratches that match the bite pattern of another Cryolophosaurus. The way the bones were broken suggests it wasn't just a random attack, it was feeding. It hunted hard, and apparently ate harder, so hard it might have killed itself trying. One Cryolophosaurus may have choked to death with a prosauropod still stuck in its throat. And if you're wondering what unlucky prey it may have choked on, well, odds are it was this guy, Glacialisaurus. Also discovered in the Hansen Formation, Glacialisaurus was a primitive sauropod, part of the early family tree that would eventually lead to the towering long-necked sauropods of the Jurassic and beyond. But Glacialisaurus wasn't quite a giant yet. It was roughly the same size as Cryolophosaurus, about 20 to 25 feet long, weighing in at an estimated 4 to 6 tons. A big, plant-eating body on slow-moving legs made it a top pick on the Cryolophosaurus menu. We don't even have a full skeleton, just a partial femur, some ankle bones, and a few foot elements. Glacialisaurus was the first sauropodomorph ever excavated in Antarctica, and that's a huge deal. because it means that even this early in the Jurassic, sauropodomorphs were already spreading across the globe. With both Glacialisaurus and Cryolophosaurus preserved here, the Hansen Formation stands out as one of the most important fossil sites on the continent. But as important as the Hansen Formation is, with its early dinosaurs, it's not the oldest window into Antarctica's past. To go deeper, we have to rewind even further, back to a time when Earth was still recovering from the worst extinction event in its history, the Permian-Triassic extinction, or as it's often called, the Great Dying. An event so devastating, it wiped out over 90% of all species on the planet. The world was quiet, scarred, starting over. Life was still figuring itself out. Mammals, reptiles, or something in between. And that brings us to the Freemu Formation. Tucked into the Transantarctic Mountains, just like Hansen, these layers take us more than 240 million years back in time. Antarctica, then, was still part of the supercontinent Gondwana, and its climate was surprisingly mild, something like modern-day New Zealand. In this period, one genus didn't just survive, it took over. Lystrosaurus. It wasn't a dinosaur, but something even older. A therapsid, part of a group more closely related to mammals than reptiles. And in the early Triassic, it became the ultimate survivor. In some fossil beds, Lystrosaurus makes up nearly 95% of all land animals found. That's not just common, that's a total takeover. So, how did it pull that off? Simple build, smart adaptations. Lystrosaurus had a tough, barrel-shaped body and strong front legs, great for digging. Its face ended in a beak with two small tusks, probably used to root through dry ground for plants. Some fossils even hint it could hibernate, maybe curling up in burrows to wait out the worst seasons. And it wasn't just local. This thing was everywhere. Fossils have turned up in Antarctica, India, China, Mongolia, Russia, and South Africa. That's a global comeback after the planet's worst extinction. It wasn't flashy. It wasn't fierce. But in a broken world, Lystrosaurus was exactly what survival looked like, and while it outcompeted others, it wasn't alone. Sharing the same terrain, and in some cases, even the same burrows, was another survivor, Thrinaxodon, also a stem mammal, but with a very different destiny. While Lystrosaurus dominated the land and eventually faded into extinction, Thrinaxodon played the long game, quietly laying the groundwork for all mammals. It was small, about the size of a fox. Its body was likely covered in hair, hinting at warm-bloodedness, a trait that helped it survive in the cold, dark corners of ancient Gondwana. It had a secondary palate too. This adaptation allowed it to breathe while chewing, a game-changing upgrade for feeding efficiently. Its teeth had already started to look familiar. Canines for grabbing, molars for crushing. It was a predator, showing signs of the complex jaw mechanics that mammals would later perfect. And maybe most touching of all, fossil evidence suggests Thrinaxodon was among the first life forms to care for its young, nurturing them in burrows, protecting them. A flicker of parental care at a time when most life was still ruled by instinct alone. We don't know of any apex predator from this time in Antarctica. Not yet. But it's hard to believe there wasn't one. Something at the top of the food chain, keeping even the tough little survivors on edge. Maybe it's lost to time, or maybe we just haven't found it yet. What we have brought to light is Prolacerta, a small, slender reptile with a long neck and serrated teeth. Not exactly a terror, but maybe bad news if you were a hatchling Lystrosaurus or a young Thrinaxodon. Still, it wasn't all sunny afternoons, especially not near the riverbanks or shallow waters. Because lurking there was something strange, an animal with the head of a fish and the body of a crocodile. Antarctosuchus. Discovered only in Antarctica, all we've uncovered is a skull, but even that gives us a strong sense of what Antarctosuchus was and the role it played. This large, flat-headed amphibian, measuring over 2 feet in length, bore a striking resemblance to a crocodile, yet it was entirely different. Its skull, adorned with numerous small teeth, suggests a diet of small prey, possibly invertebrates, and its well-developed sensory canals indicate an aquatic lifestyle. Its unique features set it apart, making it a distinctive inhabitant of Triassic Antarctica. By the late Cretaceous, Antarctica still had secrets to keep. Dinosaurs, like the armored herbivore named Antarctopelta, and predators like the imperabator, we know mostly from fragmentary fossils, roamed these ancient lands. But whatever they were, whatever else was out there, it all changed with the impact. After the age of dinosaurs, aka the Mesozoic, came another upset. The asteroid. A single impact, sudden, global, unforgiving. And even here, at the bottom of the world, life felt it. On Seymour Island, where the La Meseta Formation now sits, we find a graveyard. Thousands of marine fossils, clams, ammonites, and more, gone in a geological instant. A silent record of just how far the extinction reached, but also a record of what came next. Because Antarctica didn't fall, it adapted. Forests still clung to the coast, rivers still ran, and in the shadow of that catastrophe, new giants rose. The Eocene, a time when Antarctica was more open and connected than it is today. Though no longer part of a supercontinent, it hadn't yet settled into its polar isolation. Land bridges linked it to South America and, intermittently, to Australia, allowing species to migrate and ecosystems to intertwine. Among the most striking of these ancient inhabitants were the terror birds. The only proof we have of these apex predators is a few giant foot bones. From those fragments, scientists estimate a bird tipping the scales at about 100 kilograms and standing close to 2 meters tall. These remains most likely belong to Phorus rhacos, or a close cousin. Their beaks had hooks like cleavers, probably used to give fatal blows to their prey, and legs were built to sprint up to 30 miles per hour. They were apex predators of the food chain before large mammalian carnivores took over. But even the deadliest predators don't rule alone. They need something to hunt. And in those ancient forests, plenty of unlucky life forms fit the bill. Among them was an ancient, now extinct family of mammals. They migrated through this corridor too, some settling in Antarctica, others continuing on to Australia where they'd radiate into dozens of forms. But these were no modern hoppers or climbers. The best known among them were the Antarctodolops, small, resilient inhabitants navigating through Seymour Island. But here, in the forests of ancient Antarctica, some of them likely met their end, in the path of the sprinting, razor-beaked killer. Terror birds weren't the only giants on the continent, because while they dominated the land, a rival of equal size had claimed the sea. And unlike the terror birds, this giant wasn't a visitor, it was native. We call it the Colossus penguins. They stood eye to eye with the tallest basketball players. At least 3 massive species roamed these ancient coastlines. Their fossilized bones, scattered across Seymour Island, tell us that they may have stretched nearly 2 meters long and weighed over 100 kilos. We don't know exactly why the Colossus penguins vanished, but the clues are clear. As Antarctica cooled, new rivals arrived. Faster, sleeker marine mammals like early whales and seals. The balance tipped. Size alone wasn't enough anymore. Outpaced, outcompeted, and slowly gone. And as the giants faded, the continent itself changed forever. Tectonic forces kept working in silence until finally the last ancient bridges snapped. First to Australia, then to South America, and the oceans responded. Water began to circle the continent in an unbroken current, fast, relentless, and cold. This was the birth of the Antarctic circumpolar current. It locked Antarctica in a deep freeze, cutting it off from the warmth of the world. The forests? Gone. The rivers? Ice. The inhabitants that once ruled? Just bones and stone. Today, it's a frozen memory. And though it's gone, its story is still being uncovered, one fossil at a time. Bit by bit, we're learning how it lived and how it ended.